Today we're going to look at the last topic in partial differentiation. That is the derivatives of multivariable functions. And we are going to look at the method of Lagrange multipliers. And this is due to the mathematician Lagrange. He's a famous mathematician, especially in the area of multivariable functions. So if any of you all are doing research on any mathematicians, this is a good, Lagrange is a very good one to look into, okay? So Lagrange multipliers enable us to find the extrema of functions subject to some constraint. For example, if you want to maximize the volume of a box with a particular surface area, you'd use your Lagrange multipliers. So your constraint would be surface area. Now let me make a note here. Everything that we're going to do today, right, you could do it based on what we did in the last lecture. As a matter of fact, some of the questions that we did, you remember the word problems? I think there was one with volume. You could use Lagrange multipliers. It may work out quite easier for you, okay? So for example, if you want to maximize, say, profit subject to budget dollars, something like that, that is your Lagrange multipliers. So let me give you the method. It's a formula. So let me give you the idea behind the formula, and then we'll do quite a number of examples. Suppose we want to find the extrema max min of f of xy subject to the constraint g of xy equals k. What that means is we want to find the extreme of f of xy where xy is restricted to lie on the level curve g of xy equals k. Okay, let's do that. We want to maximize this function of two variables f of xy. So remember I told you a three-dimensional plot can be drawn as a two-dimensional plot using level curves, right? So let's draw the level curves of f of xy. So let's draw, let me do the x and the y axis. And let's just say these are three level curves, okay? And we can call them anything. Let's say this one is f of xy equals, say, 11. This one is f of xy equals 10. You know, anything. F of xy equals 8, right? And then in blue, I am going to draw the curve, the constraint, g of xy equals k. So let's say it looks something like this. And let's call this point of intersection here x0, y0. So remember what we're trying to do here? Maximize the function f of xy subject to that constraint. What does that mean? And remember we represented f of xy by a lot of level curves. Maximum means find the largest value of f of xy. So basically we want to find the largest c, the largest constant, such that the level curve f of xy equals c intersects g of xy equals k. All right, that is how you maximize it subject to that constraint, okay? So let's just say that it's at that point, x0, y0. What does that mean? Let me take another thing here. Let's take a medium point here. Where these curves, where g of xy equals k intersects the level curve, that is where there is a common tangent line. Right? Now, if there is a common tangent line, that means the gradient, do I have another color here? No, I don't. That means, let me use this here. The gradient vectors are parallel. Remember the gradient vector is perpendicular to the level curves? The gradient vectors are parallel at that point. So in other words, we can come up with this. When two vectors are parallel, what does that mean from earlier on? One is a multiple of the other, right? So the gradient vector for the function f of xy at the point is del f at x0, y0. The gradient vector of g of xy is del g at x0, y0. If they are parallel, then one is a multiple of the other. I call this multiple lambda, and lambda is called the Lagrange multiplier. Right? Okay, so we need to kind of look at this very important formula, right? And how do we get the maximum or the minimum? Look at that equation and solve for x and y. So you are going to get a bunch of equations. Now this is the most difficult part of this, to solve these equations. So I'm going to do quite a few examples to show you different tricks that you can use. Okay? All right, so let's do this. So to find the maximum and minimum values of the function, and I put in x, y, and z just in case, because you may have a function of 3 variables, subject to the constraint g of x, y, z equals k, using the method of Lagrange multipliers, means find all the values x, y, z, lambda, such that del f of x, y, z equals lambda times del g of x, y, z, and the constraint is also true. G of x, y, z equals k. So these two formulas you must solve. These equations, you must solve. And what you do, you evaluate f at any of the points that you find. The highest value is the max, the lowest is the minimum. Now, what I'm going to show you now is how you solve these. Well, let's set up the system of equations and see what you get. So how do we find the points x, y, and z? We solve these 4 equations. Where did these come from? Let me show you. So I'll put y. Okay, so we start off with del f at x, y, z equals del g times lambda at x, y, z. Okay, so remember, that is what we're trying to solve. Now remember, what's the formula for the gradient? It's the vector of all the first partials. So fx, gx, what am I saying? Sorry. That's not right. It should be fy. Fz. And over here it would be lambda times the vector g sub x, g sub y, g sub z. And so this says equal to, multiply everything by lambda, lambda g sub x, lambda g sub y, lambda g sub z. Okay, and then you have this here. So fx is lambda gx. From a look at it, you see up here. So all you do, you just equate corresponding components. F sub x is lambda gx. You see that? Fy lambda gy, fz lambda gz, and always stick in the constraint. So basically, you have 4 equations to solve. If it was a function of 2 variables, you wouldn't have so many. You may have 3. All right? All right. So now let's go through some examples. And it's all going to come together. So find the maximum value of this function subject to the constraint x squared minus y equals 1. So what you're going to do is to write out the 2 functions f and g. So I'm going to put f of xy over here. Now really, I should have really put 2 pages for each of these questions. They can be really long. So don't write too big, okay? And then g of xy is your constraint, but make sure you put it equal to 0. So it's equal to x squared minus y minus 1. Okay? Now, what you're going to do, based on the 4 equations we had, for each of these, find the first partials. Okay? So f with respect to x is 2x plus 2y plus 2. F with respect to y is 4y plus 2x plus 3. And let's go over here. G with respect to x is 2x. G with respect to y is minus 1. Okay? Now bring in lambda, the Lagrange multiplier. So it will be fx, so you'll have 2x plus 2y plus 2 equals lambda times gx. So 2 lambda x. Okay? Now, I think we can reduce this. So divide everything by 2, make it look a little neater. So that implies that x plus y plus 1 is lambda x. Call this 1. Next equation, take this partials with respect to y now. 4y plus 2x plus 3 equals, multiply the gy by lambda minus lambda. There's nothing we can do there, so call this 2. And then your final equation is always your constraint. So x squared minus y equals 1, 3. Okay, now this is where you have to look at these 3 equations. The thing is, we're trying to solve for x and y. You can do these a number of ways. You can try to eliminate lambda, maybe solve for lambda and substitute. You have to look for ways of doing this. Okay, so that is why I'm going to look for a lot of tricks. Now, if you notice there, the third equation is a really nice equation that I can solve for y. So what you're trying to do, look for the nicest equation. That's one of the tricks. And see if you can solve for one variable. Okay? So from here, this tells me that y equals x squared minus 1. Okay? So therefore, remember, let me just say something. When you're trying to solve a system of equations where you have more than 2 variables in there, try to eliminate one. If you see a system with just 2 variables, that's good to solve. But 3 or 4, you're running into trouble. Okay? So try to eliminate one. So that is why I solve for y. And I am going to replace y in the other 2 equations by x squared minus 1. This will therefore leave me equations with just x and lambda. Okay? So I'm going to say substitute 3 into 1 and 2. Okay, so let's see what we get. So 1 becomes, so x plus y, which is x squared minus 1 plus 1 equals lambda x. So this looks a little nicer. So the ones cancel, so x plus x squared equals lambda x. Okay, we're getting somewhere. Let's just call this 4 because it does not look like something we can do anything with yet. Now take 2. 2 becomes, do the same substitution. 4 times y, so that's 4 times x squared minus 1 plus 2x plus 3 equals minus lambda. Simplify the left side. 4x squared plus 2x minus 1 equals minus lambda. Call this 5. Okay. Now please don't go back to 1 and 2. You have dealt with it already. You now have two new equations, 4 and 5. Can we solve that? Look at it.
Yes.
Yeah, because we have something for lambda, right? Number 5. We have a value for lambda. We can take it and plug it into 4. Okay? So substitute 5 into 4. Okay, so 4 becomes x plus x squared equals x times lambda. From 5, lambda is minus 4x squared minus 2x plus 1. Now we get in somewhere. Now this is something that we can solve. We only have one variable, so let's do it. Distribute and solve for x. X plus x squared equals minus 4x cubed minus 2x squared plus x. So this gives us 4x cubed plus 3x squared. The x's cancel and that's 0. Now let's factor. Factor out x squared. Oops, let me take this out a bit. Oops, where did that come from? X squared, you have 4x plus 3 equals 0. So x is 0 or minus 3/4. We are getting somewhere. We have what x is. That's beautiful. You remember what we're trying to get is x and y, right? So when x is 0, tell me, how can we find y? Where do I put that? Right, into the constraint. Y equals x squared minus 1, right? So, substitute in y equals x squared minus 1. X equals 0 gives us y equals minus 1. X equals minus 3/4 gives us y equals minus 7 on 16. So our critical points are therefore 0, minus 1, and minus 3/4 minus 7 over 16. All right. Now, the good thing about Lagrange multiplier is when you use it, you must get an extremer. It's either max or min. All right? So, you need to decide, what is the question asking us? To find the maximum, right? So, you need to find the value of the functions at these 2 points. So, take these points and put it into the original f. All right? So, you are oops, I don't have much space, so I'll just give you the answer. F of 0 minus 1, upon substitution you get minus 1, and f of minus 3/4 minus 7 over 16 upon substitution gives you minus 155 over 128. Choose the larger of these values. The larger one is this one here. And so this is your max. Done. So this is your solution. So that was one method. So I'm going to do, as I said, a few examples because you have so many ways to solve these equations. You just have to try, okay? Let's go on. Number 2. At what point on the circle x squared plus y squared equals 1 is the product f of xy a maximum, and a little a is missing from maximum. Okay, so what are you trying to maximize? Xy. So this is going to be your function f. So write it down. Do not mix up your f's and your g's. Okay? Your constraint g of xy is going to be x squared plus y squared minus 1. Any questions so far? Now let's do it. You're going to find the first partials for both of these. Partial f with respect to x is y. Oh, why is this doing this to me today? Partial f with respect to y is x. Partial g with respect to x is 2x. Partial g with respect to y is 2y. Let's write out our 3 equations. So the first two, you need to bring in the lambda. So the first one, y equals 2 lambda x. So we connect the fx with the gx. There's nothing we can do with this, call this 1. Cannot be simplified. Next one, connect the fy's with the gy's. X equals 2 lambda y. Call this 2. And your last is always your constraint. X squared plus y squared equals 1. Call this 3. Now let me show you another trick. All right? Again, there are different methods you can use to solve this one. I'll just show you one method. If you look at number 1 and 2, you can solve for lambda. From number 1, lambda equals y over 2x. From number 2, lambda equals x over 2y. Lambda is the same. Lambda is unique. So this means these two must be the same. So from this, y over 2x equals x over 2y. Now this should be making a little bit of sense to you. All right, because we now have an equation, or an equation of just x and y. Cross multiply, this implies that 2y squared equals 2x squared. Solve, x squared is y squared, or y squared is x squared. Now what I'm going to do is to substitute into 3. Right? So substitute into 3. And that's an easy substitution because we can substitute for y squared. Y squared is x squared. So what does 3 become? X squared plus x squared equals 1. Solve. Looking good. 2x squared equals 1. X squared is a half. So, square root both sides, x is plus, don't forget to put plus or minus, 1 over square root 2. And remember, x squared is y squared, right? So this should tell you that y is also plus or minus 1 over square root 2. Same thing, right? X squared is y squared. So we have solved for x and y, and notice we have 4 points there. I hope you noticed that. There are 4 points. So let's draw a little table then, because we need to find the value of f at these points. So let's draw a table like we did before. Let's put the point here, and let's put the value of f. So we have 1 over square root 2, 1 over square root 2, 1 over square root 2, minus 1 over square root 2, minus 1 over square root 2, 1 over square root 2, minus 1 over square root 2, minus 1 over square root 2. Okay. Now what's our f again? F of xy is xy, right? So substitute these points into f of xy equals xy, and what do you get? So you just multiply x by y. That's a half, minus a half, minus a half, a half. What is the question asking us? At what point is a max? So we're looking at which 2 points? The first and the last, right? So the points are 1 over square root 2, 1 over square root 2, minus 1 over square root 2, minus 1 over square root 2. Done. So that was yet another trick. Okay, any questions so far? Okay. Number 3. Find the points on the sphere x squared plus y squared plus z squared equals 1 closest to and farthest from the point 1, 2, 3. I don't know if you remember the last lecture we did a question like that. I think we minimized distance. Right. So that's another one, but we're going to do it using Lagrange, right? You still have to do the same thing you did before. Find the function. So what is this question asking us? Closest to and farthest from the point means you want to minimize and maximize distance. Okay? So you choose, like we did the last time, choose an arbitrary point xyz and find the distance between xyz and 1 to 3. Okay? So let's do that. Choose an arbitrary point x, y, z. Distance between x, y, z and 1, 2, 3 equals the square root of x minus 1 squared plus y minus 2 squared plus z minus 3 squared. So this is the function we have to maximize and minimize. But remember what I said the last time. What did I say about this function of the square root? Take out that square root, it's in the way. Alright? So really, we want to minimize as closest to and farthest from, right? So we want to minimize and maximize f of x, y, z equals x minus 1 squared plus y minus 2 all squared plus z minus 3 all squared. Okay? And of course, subject to that, I'm constrained. X squared plus y squared plus z squared equals 1. Remember how we did that the last time, last lecture? We substituted, remember, z, the value for z into the function. And we used our what we did before with our D, you know, but let's do it using Lagrange. Okay, let's write out our two functions. All right, so we have f of x, y, z, which I'm writing again, x minus 1 all squared plus y minus 2 all squared plus z minus 3 all squared. And then g of x, y, z equals x squared plus y squared plus z squared minus 1. All right, we have to find the first partials. We have a function of 3 variables, so we have 3 first partials to find. Okay, so let's do it. Fx is 2 times x minus 1. Fy, 2 times y minus 2. Fz, 2 times z minus 3. Go over. Partial of g with respect to x, 2x, gy, 2y, gz, 2z. Bring in the lambdas now. So the left equals lambda times the right. Let's do it. 2 times x minus 1 is 2 lambda x. Now reduce that. Divide by 2. So x minus 1 equals lambda x. Call this 1. Next. 2 times y minus 2 is 2 lambda y. This tells us that y minus 2 is lambda y. Call this 2. 3. 2 times z minus 3 equals 2 lambda z. This implies that z minus 3 is lambda z. 3. Okay. Now, and of course, we forgot the constraint. X squared plus y squared plus z squared equals 1. Yet another trick. Look at these 3 equations. The first 3. What can you do with these? You can also, yes, so I heard somebody tell me solve for lambda, right? You can do that, but you know what's going to happen? The 3 variables, that's the problem. Because if you solve for lambda, you have 1 lambda equals another lambda equals another lambda. You know you're still stuck with 3 variables. It will work, but it will take some time, right? I was able to do it on the last question because I only had 2 variables. But here's a little strange. So what I would do, I wouldn't solve for lambda. In each 1, 2, and 3, I would solve for the variables. I can solve for x in 1, I can solve for y, I can solve for z. All of these will be in terms of lambda, and I can put it into 4. Okay, so let's see. So 1 becomes, so I'll bring the x's to one side. So x minus lambda x equals 1. Factor out the x, 1 minus lambda equals 1. So this tells me that x is 1 over 1 minus lambda. Number 2. Y minus 2, well, let's subtract lambda from both sides right away, just to save some space. So 2 becomes y minus lambda y is 2. Factor out y, 1 minus lambda is 2. So y is 2 over 1 minus lambda. And then number 3, z minus lambda z is 3. Factor out z, 1 minus lambda is 3. So z equals 3 over 1 minus lambda. Now this is making a little sense. So take these three values we just got and put them into 4. So therefore, we'll only have an equation with lambda. So 4 becomes x squared, that's 1 over 1 minus lambda squared, plus y squared 4 over 1 minus lambda squared, plus z squared 9 over 1 minus lambda squared equals 1. Any questions? Simplify all of that on the left. 1 and 4, 5, 5 and 9, 14. 14 over 1 minus lambda all squared is 1. Cross multiply. 1 minus lambda squared is 14. Square root of both sides, 1 minus lambda is plus or minus square root 14. And so lambda is 1 plus or minus square root 14. So we have lambda. Now we want to take all of these values for lambda and substitute. Let me draw a little arrow to show you where you're going. You want to take this and substitute into here. And that will give you your x, y, and your z. So let's do that. Okay, we have 2. Okay, so lambda equals 1 plus square root 14 implies that your x, y, z point. So you're taking that and putting it into these up there. Lambda equals 1 plus square root 14. And you're going to get x is minus 1 over square root 14. Y is minus 2 over square root 14. Z is minus 3 over square root 14. Now, right away, I'm going to find f at that point. And f at the point x, y, z there would give you 14.2. So that's the first point, first lambda. Any questions so far? Take the other lambda, 1 minus square root 14. Lambda equals 1 minus square root 14. Substitute it again to find x, y, z. And you will get positives now. 1 over square root 14. 2 over square root 14, 3 over square root 14, and substitute that into your function, and you are going to get approximately 11. So the question is asking us which one is closest to, which one is farthest from. So this one is farthest, and this one is closest. Fourth question. Now this should look familiar to you. Is that the one that we did some time ago? It looks familiar, but let's just see. Find the dimensions of a rectangular box with fixed volume 1000 and minimum surface area. So in other words, we want to minimize the surface area. So the surface area is going to be our function f, subject to the fixed volume of 1,000. So our constraint is going to be our formula with volume. Okay? Now we need to find the surface area of a box. So let's draw. I always like to draw these things when you can see it. So draw the box. Give the box variables as dimensions. It's a rectangular box. X, Y, Z. And so let's find the surface area. So it's a closed box, so the bottom is xy, the top is also xy, so that's 2xy. One of the sides xz, and it's always twice, so 2xz. And the last one is 2, what am I missing? YZ. So this is what we're trying to minimize. Okay? Let's write out our functions. So f of x, y, z is 2xy plus 2xz plus 2yz. Oh, and by the way, we forgot to write out our volume. Let me write it on top of this f. What is the volume? What is the volume of this box? XYZ, right? And that's equal to 1,000. Agreed? So what is our constraint? G of XYZ is XYZ minus 1,000. Okay? So now that we have written down these two functions, let's find the partials. Partial of f with respect to x is 2y plus 2z. With respect to y, 2x plus 2z. With respect to z is 2x plus 2y. Partial of g with respect to x is yz. With respect to y is xz. With respect to z is xy. Bring them all together. So let's bring in the lambdas. Left equals lambda times the right. So first equation, 2y plus 2z is lambda yz. Call this 1. Nothing can be done with that. Leave it alone. 2x plus 2z equals lambda xz. 2. 2x plus 2y equals lambda xy 3. And the last one is always a constraint. People sometimes forget this one. XYZ is 1,004. Now here goes another trick. As a matter of fact, this question can be solved the same way we did number 3, what we just did. But I want to show you just another trick. And this is a beautiful trick. I could have used this trick in the last question and also I think in number 2. And this is how I know I can use that trick. Look at the variables after the equal sign in 1, 2, and 3, right? They all look kind of the same, right? Except they would be the same if I had an x in number 1, if I had a y in number 2, if I had a z in number 3, right? If I had lambda xyz, that'd be good. So why can't I do that? Why can't I multiply number 1 by x, number 2 by y, number 3 by z? Right? That would make all the equations the same. Let's see what's going to happen. And so that's another trick. It's a beautiful trick. So multiply by x. So number 1 becomes 2xy plus 2xz equals lambda xyz. Multiply number 2 by y. 2xy plus 2yz equals lambda xyz. Multiply number 3 by z. 2xz plus 2yz equals lambda xyz. Look at what's happening. Just look at the first two equations. Right? The right side is the same. The first two are the same. So therefore, this has to be the same. That should tell you that x equals y. I hope you've seen that. All the equations are the same.
Can you plug in the value of x, y, and z?
We're going to do that now, in a little while. Not yet. We need to solve. Take 4, let me call these 4, 5, and 6. We need to solve for 4, 5, and 6. Solve x, y, and z in these. Here is the trick. All of these are equal to lambda x, y, z, agreed? So they are all the same. You have a question?
Yeah, it should be 6, 7.
5, 6, 7. Thanks. What was I saying? Do you agree that all the equations are the same? They're all the same. So if the first two equations, then you have 2xy, the same 2xy's, then these two should be the same. So that means x should be equal to y. Similarly, look at 6 and 7. They're the same, right? You have 2yz the same. So therefore, these two should be the same here. So y is equal to z. So from 5, 6, 7, that should tell you that x equals y equals z. That is my trick. Okay? From 5, 6, 7, x equals y equals z. So now we can plug into 4. They're all the same. So 4 becomes x cubed equals 1000. So x is 10, y is 10, z is 10. You're done. The question is asking you for the dimensions. Done. So I've shown you quite a number of methods that you can use, right? All right. The other question, let's do it together. I have do by it, but let's just discuss it. Let's do it together, okay? Find the maximum and minimum values of f of xy equals y squared minus x squared subject to that constraint. Okay, let's go. Write out your two functions. F of xy, y squared minus x squared, g of xy, a quarter x squared plus y squared minus 1. What's the next step? Partials. Can one person give me partial of f with respect to x, please? Minus 2x. Somebody give me partial of f with respect to y, please. 2y. Another person give me partial of g with respect to x, please. Half x. Another person give me partial of g with respect to y, please. 2y. Good. Can somebody tell me what is the next step? Bring in the lambda. So give me the first equation with the lambda, please. One person. minus 2x equals a half lambda x. Next. So that's 1. 2y equals lambda 2y. Well, 2 lambda y. Let me just. Any more? 1/4 x squared plus y squared equals 1. Okay, now you know we have to solve these three. Suggestions. What should I do? You want to solve for lambda? And which one? Oh. If you saw, okay, try it. Tell me, when you solve for lambda, do it on your own and tell me what you get. Tell me if that makes sense. Just try to solve for lambda. As a matter of fact, yeah, okay. Try to solve for lambda. Take number 2 and solve for lambda. What do you get?
1.
Let me just do it on the side. Tell me what to write. Because you tell me solve for lambda, right? So tell me. How would you solve for lambda?
Divide by 2, divide by y.
So divide by 2, you'll get y equals lambda y. That's why you're going wrong. You cannot divide by y. Why? Y could be 0, right? Good. So what should you do instead? You're on the right track. I love what you did here, but I wouldn't divide by y. What would I do? No, don't plug it in yet. You should be able to do something with this. This is algebra. You can subtract. Good. So let me write that. So you want to deal with number 2. Let me write that out properly here. Do I have space? Okay, let's do it here. So that's y equals lambda y. Agreed? Then somebody said subtract. Y minus lambda y is 0. Agreed? So I've subtracted. Then what? Take y out. Beautiful. Factor out y. Y times 1 minus lambda is 0. What does that mean? Y is 0 or lambda is 1. Okay. Now let's go into 1 now. I don't think I'll have space for 1 there. So, let me shift it to the right and then I'll have some more space. So I'll put it here. Minus 2x equals a half lambda. So tell me what to do. So I did it with 2. I should be able to do it with 1, right? Tell me what to do first. Yeah, I would add 2x. You know something? You see that fraction? Then let's get rid of these fractions now. Shall we multiply by 2 first? Makes it look a little nicer, right? So minus 4x equals lambda x. So now what you told me? Add 4x, right? Lambda x plus 4x is 0. Continue. Factor out x to get lambda plus 4 is 0. So that tells me what? X equals 0 or lambda equals negative 4. Now you realize we have an inconsistency there. What is the inconsistency?
Lambda equals 2.
We have 2 values for lambda, right? That doesn't make any sense. So we need to ignore the lambda. That is why you have an or. That's why, I should have put the or. It's x equals 0 or lambda equals minus 4. Y equals 0 or lambda equals 1. These lambdas make no sense, so we're going to choose, hold on. We'll choose, in the second one, y equals 0, right? and substitute it in 3. We're going to do it later. So we're going to have 2 points, or more, maybe more than 2, because I see a squared happening there. What are we doing? Substitute in 3. So go ahead, substitute it in 3 and tell me what you get. 2. So y equals 0, that's a quarter. X squared is 1. X squared is 4. What is x here? Plus or minus 2. So therefore we have 2 critical points here. 2, 0, minus 2, 0. Agreed? Okay. So we use the y equals 0. What else are we going to use from the first one? X equals 0. Now you see why it was important we didn't solve for lambda, because it wouldn't have made sense. We would have lost these 2 solutions, y equals 0 and x equals 0. So choose x equals 0, substitute in 3. What do we get here? Plus or minus 1. Y squared is 1. Y is plus or minus 1. Your critical points are 0, 1, 0, minus 1. Yeah? Any questions? What now?
Plug in the values.
Very good. So you need to draw up your little table and find the value of f at each of these points. Two 0 minus 2 0. Zero, that's a very good point. Okay, so somebody asked, do we not use 0, 0? Because we got x equals 0 and y equals 0. But does that satisfy the constraint? Good. I love that question. That's a beautiful question. Okay, do you have the values for f? What is f of x, y? I can't remember. Y squared minus x squared. Okay, what did you get for the first one? Minus 4. Next one? No, you substituting into f, not in the constraint. The constraint is always fixed.
You said what the constraint is, it says 1/4 x squared.
Plus y squared equals 1, yeah. The point I was making a while ago is that somebody asked me, how come we did not have a critical point at 0, 0? Because we got x equals 0 and y equals 0 here. Why can't we have 0, 0 as a point? Why? Because it doesn't satisfy 3. Put 0 for x and 0 for y, we don't get 1. So don't use 0, 0. Okay? You need to use them, interchange them. Where am I? What did you get for 0, 1? 1? And 1 as well? Okay, what is the question asking us? Maximum and minimum values, right? They didn't ask us for the point. So what's the maximum value? 1. And the minimum value is -4. So you realize that's yet another trick? Yet another trick. Any questions? Okay. So that's Lagrange multipliers when we have one constraint. But you know, and realize sometimes you don't have just one constraint. Sometimes you want to maximize or minimize some function, but it's subject to quite a number of constraints, right? You can have 2, you can have 3, you can have 4, right? So I'm going to show you how you handle 2. I have seen so many constraints in my studies in mathematics. It's unbelievable. You know the type of equations you can get. So look at 2 constraints. To find the extrema of f of x, y, z, subject to the constraint g of x, y, z equals k, and h of x, y, z equals c, you find all x, y, and z such that del f equals lambda times del g plus mu times del h. What does that mean? You have 2 multipliers. So if I had 3 constraints, I would have had 3 multipliers. So you solve that, you have this first equations to set up, followed by the 2 constraints. So you have a number of equations to solve. It can get very, very complicated, okay? And in higher mathematics, you would not solve this using the conventional methods, okay? You would use some other method to solve. But we'll just do one question so you can see how intricate it can get. Let's do number 1. Find the maximum and minimum values of f of x, y, z equals yz plus xy, subject to the constraints xy equals 1 and y squared plus z squared equals 1. Okay. We want to write down 3 functions, f, g, and h. So f of x, y, z is yz plus xy. G of x, y, well, let's put z because they have 3 variables, is xy minus 1. And h of x, y, z is y squared plus z squared minus 1. Okie dokie. Now you know what we have to do, right? What do you think we're going to do now? Partials. Find the partials, first partials for all of them. Let's go. F with respect to x is y. F with respect to y is z plus x. F with respect to z is y. Done here. G with respect to x is y. G with respect to y is x. G with respect to z is nothing. H. H with respect to x is 0. H with respect to y is 2y. And H with respect to z is 2z. Okay, you're good. Right. Let us set up our equations. So let's set up the first 3 with lambda and mu. Then the constraints. Okay? Let's do it. I think we might need more space than one sheet. Alright, so the first line we have y equals lambda y. There is no mu, so call this 1. Next line. Z plus x equals lambda x plus 2 mu y. 2. Beautiful. Last. y equals no lambda, but we have a 2 mu z. 3. Okay, the two constraints. Xy equals 1, 4. Y squared plus z squared equals 1, 5. Wow. Okay. Isn't that beautiful? We have 5 equations to solve with 5 variables. Where are we going with that? Okay. The first thing you should do when you see these things, see if there is any one equation you can solve. Is there anything, any one of them that you can just look at and solve for something? There's one there. You cannot do anything if xy equals 1. What can you solve with 3? I'm not seeing what you can do with 3. Yeah, you can solve for 1. Didn't we get an equation like that in the last question? What did we do with an equation like that? Subtract. Beautiful. So y minus lambda y is 0. What does that tell you? What do I do now? Factor out the y. 1 minus lambda equals 0. So y is 0 or lambda is 1. But one of these does not make sense. Look at equation 4. Xy equals 1. Can y equal 0? No. So this does not make sense. Since y is not 0, then lambda has to be 1. Good. So we can break down something there. What can we break down? We have lambda, so use it. Take this value for lambda and put it into the equation where there is a lambda. Where is it? We just did it. Number 2. Okay. So substitute lambda equals 1 into 2 to get z plus x equals x plus 2 mu y. What does that mean? Z equals 2 mu y. Call this, shall we call it something? That's another equation completely, right? All right. We're getting somewhere, aren't we? We hope. Nice. What do we do now? There's something that we can look at number. Somebody was saying something. Yeah, look at number 3. Beautiful. Look at 3 and 6. Don't you see there's something that looks really looks good in there? There's something that we can do. And I put it to you, we can use that little trick that I showed you, where you multiply each equation by something to make them the same. And let me put 3 below there. 3 says that y equals 2 mu z, right? Can I multiply each of these equations by something to make them the same? What can I multiply if it's yes? I can multiply this by one variable. I can multiply this by one variable. If I multiply the top one by y, that's not going to help me because z. Multiply by z, multiply by y. Beautiful. So z squared is 2 mu yz. Y squared is 2 mu yz. We're getting somewhere. Beautiful. What does that tell us? Y, well, don't tell me z equals y. Z equals y, that's correct, but there's even more going on. y squared. So this implies that y squared equals z squared. Agreed? Okay, we have used number 1, we have used 2, 3. What do we do with this y squared equals z squared? Tell me. 5. Oh, yes. Substitute in 5. Isn't that beautiful? Substitute in 5. Now, you know what I'm going to do? I'm going to solve for y. So I'm going to put y squared in place of z squared because I have to use number 4 to find x, right? So we have y squared plus y squared is 1. 2y squared is 1. Y squared is a half. Y is plus or minus 1 over square root 2. Aha, we are getting somewhere. We got y, and when you do your homework, you'll be singing to yourself like this when you realize you're getting somewhere. How can I get x? Into which one? 4. Good. Okay, that tells me I don't have much space, right? But that's okay. I think I can write on these lines like I did the last time. Substitute in 4. So I'm going to write for xy equals 1. So y equals 1 over square root 2 implies that 1 over square root 2 times x is 1. So this implies that x cross multiply is square root 2. And y equals minus 1 over square root 2 implies that minus 1 over square root 2x is 1. So x equals minus square root 2. And so we are ready. Now, hello. These are only x and y. Don't forget we in 3 variables, right? We need z. We need z. Y squared equals z squared. Okay. So, well, we need to... It doesn't matter. We can substitute into 5 and solve for z, can't we? So substitute now in 5 to solve for z. So what was y squared? A half, right? So 1/2 plus z squared is 1. Z squared is a half, so this implies that z is plus or minus 1 over square root 2. Okay, you know we have a lot of points here. What is our, let me see if I can put them all together. What is our f of xy again? Okay, we need to separate this out. No choice. Okay, let's do it. The points are, I'm going to put my table as a vertical table, or else it will not hold. Okay. Do you have space? F of x, y, z. Turn your page. You don't have page. Well, get another sheet then. Okay. So where is our x? We have square root 2. We have 1 over square root 2. And then our z is 1 over square root 2 as well as minus 1 over square root 2. You see we have 2 of them, all right? I hope you all are following me. And then we have the other x and y. So x is minus square root 2 minus 1 over square root 2. We have 1z to be a positive 1 over square root 2. And then we have another z, oops, to be minus 1 over square root 2. Okay. All right, give me the f again. Let me write it in there so I will know what we substitute. Is it xy plus yz? Yz plus xy. Okay, let's work that out. What do we get here? Yz for here is a half plus xy is 1. That's 3 halves. Yz is minus a half plus xy 1, which is a half. Yz is minus a half plus xy, that's plus 1, that's a half. Yz is a half plus xy, which is 1, which is 3 halves. Okay, remind me, what is the question asking us? Both the max and the min?
Yep.
Values. So the maximum value is 3 halves. The minimum value is 1 half. Can you imagine doing that for more than 2 constraints?
Nope.
Doing it by hand?
Nope.
Nope. So you should know there are other methods to do it.
Would you do that on a computer if you needed to?
You can. Okay.